All right, so part B of section 3, chapter 5. So the last bit of theory that I need you to know from this section is how to use your power reducing formula. So we're only going to do one problem, and then this will be done, but these do take a little bit of time. So let me make sure you understand what we're talking about. So when we say power reducing, notice how you can go from a sine squared, right? We want to reduce our power all the way down to a function, so all the way to a power of 1, right? So we don't want any cosine cubes, cosine squareds, cosine to the power of 4. If you don't, then you can use power reducing formulas to reduce your formulas down, okay? So notice the language in this question. Notice it says write an equivalent expression for cosine to the power of 4x, right? All right, so we want an equivalent expression, but we want one that does not contain powers greater than 1. All right, so when everything is said and done, our answer down here should only have powers of 1. We shouldn't have any cosine squareds or cubes or fourths or anything like that, okay? So let me go ahead and show you the way we can think about this. So first off, let's you and I agree that cosine to the power of 4, right? Cosine to the 4th x, that can be rewritten, or that can be thought of as cosine squared of x raised to the power of 2. So let's start there. Cosine squared squared. Now cosine squared, we can think about that as, so that's the same as, I'm misspeaking here. So cosine squared raised to the power of 2. Let's see if you agree with me. That's just cosine squared x times cosine squared x. Makes sense so far. Sometimes it's helpful. If I had x squared to the power of 2, don't you agree with me that that's just x squared times x squared? All right, so in this case, the reason why we start there is because notice I have a power reducing formula for cosine squared. In other words, whenever I see a cosine squared, I can rewrite it as this. So we are actually going to be placing 1 plus cosine double theta over 2 in here for both of these. Let's go ahead and do that right now. So that ends up being 1 plus cosine double theta over 2 times 1 plus cosine double theta over 2. All right, so hopefully that made sense. Anywhere I see a cosine squared, I can substitute this power reducing formula, and that's exactly what I did. So let's go ahead and clean this up. What I'm going to do is I'm going to run out of space very quickly, and so I'll probably go to the next page. But let's go ahead and what I'm going to do is we're going to have to multiply numerator times numerator, denominator times denominator. So does it make sense to you that we're going to have to FOIL these numerators? I hope it does. So we're going to do that now. So let's start with the denominators. Those are easy. 2 times 2 is 4. But now let's FOIL. We got to FOIL these numerators. Okay? So 1 times 1. Then it's going to be 1 times cosine double theta. Then it's going to be Cosine of double theta times 1 is just another cosine of double theta. And finally, cosine, how do we do this? Cosine double theta times cosine of double theta. Well, fairly simple. If you have, this is actually simple, but it's important to understand. When you do cosine double theta times cosine of double theta, you just get cosine squared double theta. All right, I need to stay here for a second, because oftentimes in my math courses, I'll see students, when you say cosine double theta times cosine double theta, I will see students do things like this. Right? They're thinking 2 times 2 is 4, and theta times theta is theta squared. So they're trying to multiply the angles. And that is not the way we treat functions. So cosine of x times cosine of x is cosine squared x. Cosine of double theta times cosine of double theta is cosine squared double theta. All right, it's important to understand what I just did. All right, I'm going to scoot this forward, this denominator, over to the middle, and that's where we are. Are we done? Well, we want an equivalent expression that does not contain powers, right? Does not contain powers greater than 1. So unfortunately, we still have a problem. This cosine squared is keeping us from completing. All right. So here's what I'm going to do. The first thing I'm going to do, I think you'll find this easier. Do you agree with me? Let me make sure you understand. Do you agree with me that if you told me your age, if I divided it by 4, that would be the same thing that as if you told me your age and I multiplied by 1/4? Right? To divide by 4 is to multiply by 1/4. In my professional opinion, I think it's easier to think about multiplying by 1/4 than it is to think about dividing by 4. Doesn't matter, I agree with you. And let me do a little bit more combining in this step here. While I'm at it, do you agree? Let's make sure you agree with me. If I have cosine of double theta and I have another cosine of double theta, how many do I have? I have what? I have 2 of them. I have 2 cosines double thetas. All right, and finally plus cosine squared. All right, so at this stage, everything in the problem is okay except this cosine squared double theta. I need to fix that. So let's go ahead and do that right now. And I'm trying to think, I have a little bit of space. I don't have enough space to finish it, but I have a little bit of space. I think, can you entertain yourself for a second? Let me copy this and let me get a new page. Let's make that a little bit smaller. Okay. All right, so come on back to me. Let's come off to the side here for a second. So cosine squared of 2 theta is what we're going to try to take care of right now. All right, so think about, so do you agree? I have a formula for cosine squared, right? I have a power reducing formula. I can rewrite, tell you what I'll do. Let's go to share, let's copy, let's take this along for the ride. All right, So I have a formula for cosine squared, but I need a formula for cosine squared double theta, not just theta. So let's see if you can agree with me here. So let's start. So cosine squared theta, that can be rewritten as 1 plus cosine double theta. I'm going to adjust this in just a second. Ready? Over 2. Okay. So this formula is perfect if I have cosine squared of theta. But I don't have a theta. I have a double theta. So, in other words, I need to adjust the double theta. And it's simple enough. I mean, it's, you know, the way you can think about this is instead of having theta, you have 2 theta. So all that's required here is that we just plug in. All right, we just substitute in. So that's going to end up being, I'm going to erase this now. This is going to end up not being 2 theta, it's going to be 4 theta. Okay. I hope that makes sense. I had to adjust for this. So now what's going to happen is I'm going to take this cosine 1 plus cosine 4 theta, and I'm going to sub it in here. So let's do that now. So that's 1/4 times 1 plus 2 cosine. I'm going to get rid of these extra parentheses. I don't want them to confuse you. So 1 plus 2 cosine of double theta. I think I lied to you. I'll use a different color for these parentheses. Plus, okay, so now, but instead of using this, because I need powers, no powers greater than 1, I'm going to use this. So plus 1 plus cosine 4 theta over 2. All right. So in due reality, at this stage, we have succeeded. We have, our problem does not contain powers greater than 1. For the test that you would take with me, I would accept an answer like this. When you're doing your homework on, software like MyMathLab, they're going to want you to go ahead and distribute this 1/4 and combine like terms. In other words, let me write the answer that they're going to want it to look like. So I will, let's use a different color so that you know that we're all done. All I'm trying to do right now is show you how to write this problem using MyMathLab. So the first thing they're going to want you to do is go ahead and you can think about dividing by 2 as multiplying by 1/2. All right, and then I'm going to distribute here. Almost done, stick with me. Plus 1/2 times 1 is 1/2. And then that's going to be plus 1/2 cosine 4 theta. And finally, distribute here, 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 and here, and combine like terms. You would get 3/8 plus 1/2 cosine of 2 theta plus 1/8 cosine 4 theta. All right, so this last bit of material was just to show you how your answers should look in my math lab, but you have done all the work that I have asked at this stage here. It's a little bit sloppy, I agree with you, but this is what I'm looking for. Okay, so we'll let that conclude 5-3, and I will see you guys in the next video.